Okay, today we're going to cover 6.1 and 6.2, and in 6.1 we're talking about polynomials. We're going to define what a polynomial is, and then the degree of a polynomial and how many terms a polynomial has, the leading coefficients. These are all things that we're going to talk about today. Monomial and polynomial, you'll probably notice the prefix here. Mono means one and poly means many. So just having awareness of that. Here's some examples of what are polynomials and what are not polynomials. Just things to notice here. Polynomials have exponents that are whole numbers, and not polynomials have things like exponents that are variables, absolute value, exponents in the denominator, roots, so on. The degree is going to refer to the term and the exponent, or the sum of the exponents of the variable, so we'll talk about that. Jump over to the next page, start talking about degree. The degree, again, refers to the sum of the exponents. So in A here, if you look at what this monomial x to the fourth is, as far as the degree of that would be 4, because it is to the fourth power. B, this one right here, would have a degree of 0, because technically this is 12 x to the 0 power. Nobody writes that, but it's there. C, this one's a little weird because we have multi-variables in here. We have a squared and a b, so the total degree of that is 3. You don't really see that a lot, but it does, I guess, technically come up here if you did have multiple variables in a polynomial. Usually we just have one x. Same thing with D, so this one, the degree of this is going to be 3 plus 4 plus 1, so a total of 8. All right, so the degree, if we list the degree down here, the degree for 1a would be 3, the degree for 1b would be 0, this one would be 5, and this one here would be 9. Okay, so identifying the degree, those are all monomials. All right, so what if we had the degree of a polynomial? This is probably a little more common to talk about degrees of polynomials. So the degree of a polynomial is based on the term in that polynomial, because a polynomial is made up of the sum or difference of a bunch of monomials. And so whichever monomial has the highest degree is what we are going to call the degree of the polynomial. So if we look at this example down here, 5x cubed plus 8x squared plus 3x minus 17, that's organized, and this is called standard form. And you always should write your polynomials in standard form. And what that means is we have the highest degree monomial plus the next highest degree monomial plus the next highest degree monomial, and then the last is the lowest degree, which is the constant. So you should always have it in descending order from the highest degree to the lowest degree. And so 5x cubed is the highest degree, so we would say this is a third degree polynomial. All right, so we start, there's two ways to classify here. We classify it by degree, and we classify by the number of terms that the polynomial has. So here's some special classifications for those degrees. So if it's 0 degree, we call that constant, and that doesn't have a variable, so that's just a number, like -9. If it's linear, that's to the first power, so anything that is to the first degree is a linear. Second degree quadratic, third degree cubic, fourth degree quartic, fifth degree is quintic. I'd say quadratic and cubic and linear are probably the most common. And then we also have special terms for if a polynomial has one term. One term, we covered that already on the first page. That is a monomial. That's what mono means. So monomial is one term. If it has 2 terms, that is a binomial. If it has 3 terms, that is a trinomial. So just classifying those polynomials by their degree and their number of terms they have. So if we take some examples of that, we'll ask you maybe to, well, we'll always ask you to write it in standard form. So here's some examples here you can pause and look at from the book. If we go down here to these examples and we rewrite these, we want to look at each term, each monomial that's made up of this. Now there's 3 terms, so this is a trinomial. And we want to put the highest degree term first, so that would be a negative 2x squared plus 4x plus 2. Okay, that's in standard form, so we would call that, you would always say the degree first, so that is a quadratic, because it is second degree, so it's a quadratic, and there's 3 terms, so it is a trinomial. The other one, this has 4 terms, so highest degree term first is a cube, so that's x cubed minus 18x squared plus 2x minus 5. This is in standard form now because it is highest degree to lowest degree, and it is because it is to the 3rd power, we call that a cubic, and then it has 4 terms, so anything more than 3, we'll just say it's a polynomial. So that is a cubic polynomial. So being able to write in standard form and then label it by degree and by number of terms. Okay, the other thing we're going to talk about in this section is talking about adding and subtracting polynomials, which really this is not a new topic. So if you're adding and subtracting polynomials, you just have to make sure to combine like terms. And so if I was going to add these 2 polynomials together, they both have 3 terms, so they're both trinomials. This first one would be a quartic trinomial, it's 4th power. This one on the right would be a quadratic trinomial because it's the 2nd power. So if we add those, we just have to combine like terms. So there's only 1 term to the 4th power. There's no cubic terms. There's 1 term to the 2nd power, so minus 7x squared. Here's a couple like terms right here, so we combine those to make 7x. And the constants combine for a total of negative 15. So now that turned into a 4th degree polynomial. So just combining like terms really. If you have subtraction like this, you really got to be careful to not forget to distribute that negative. So that negative goes all the way to all those terms. Excuse me. So really this is a minus 2x plus 7x plus 8. Combine like terms and put it all together. So now we have 4x to the 4th. Instead of minus, now we have a plus 7x squared. And we have 5x plus 7x is a total of 12x. And negative 7 plus 8 now is plus 1. Okay, so just combining like terms, distributing negatives, really adding and subtracting polynomials, there's nothing new here. We're going to go to multiplying polynomials just a sec. Okay, so we jump over to 6.2 now, and 6.2, we combine these two because there's really not a ton in here. So 6.2 is multiplying polynomials, which really is not a new topic. It's just talking about distributing and foiling. So I'll talk here about multiplying polynomials. Let's say we have a monomial times a binomial. So what is that going to result in? Well, a monomial is 1 times a binomial is 2, so that's going to result in 2 monomials, right? Because a binomial is the sum or difference of 2 monomials. If we have a monomial times a trinomial, this is kind of like distributing 3 times, so we'd have 3 new monomials, and so this is going to end up being a trinomial. So just talking about that distributing. If we have a binomial times a binomial, this is where you have the precious FOIL. So we have first, outside, inside, last, right? Okay, FOIL only works for binomials times binomials, so that's why it's kind of, you can really only use it for that. If you take a binomial times a trinomial, now we have to take, and so this is where I think people get confused. They're like, well, how do I FOIL this? There's not enough letters. Okay, well, that's why FOIL's kind of dumb, I think. So you take that first term and you just multiply it by all the terms in the trinomial. Take that second term in the binomial and you multiply it by all those terms in the trinomial, which gives you the sum or difference of 6 monomials. Combine your like terms and write it in standard form. So let's go ahead and just do some examples together. Let's say we have, let's pick a fun color here. Let's go with that one. I like that one. Say we have a binomial times a trinomial here. So how many different products is this going to be? We have a 2 times a 3. That's going to be 6. So I like to just, one way I organize it is just write out my 6 little blanks. And let's distribute that 3b first. So multiply the 3b by all those terms. And we are going to end up with 9b cubed minus 3b squared c minus 6bc squared. Okay, now we do the negative 2c. Negative 2c times 3b squared is going to be negative 6b squared c. Negative 2c times negative bc is negative bc squared, positive 2bc squared. And then the last is going to be negative times negative is a positive 4c cubed. So this one's kind of messy because we have two different variables. So do we have any like terms here? Let's see. We have a b squared c term here, and we have a b squared c term here. And then we also have a bc squared there and a bc squared there. So if we rewrite this in standard form, we pick a variable. Let's just stay with b. So we go 9b cubed is first, minus 9b squared c. And then we have minus 4bc squared plus 4c cubed. Right, so that's how you'd multiply a binomial times a trinomial. Okay, here is a trinomial times a trinomial. So there's a couple ways to organize this. When it gets to be this big, I actually like to use what's called like an area model or a box method, I guess. And this will just make sure all my like terms are lined up. All right, so we have x squared minus 4x plus 1. And we have x squared plus 5x minus 2. That's just like a multiplication chart. So now I'm going to go fill this in. X to the 4th, x to the x squared times negative 4x. That's going to be negative 4x cubed plus x squared, 5x cubed. Okay, and if I didn't make any mistakes, now all of my like terms are going to be lined up on diagonals like that. You know, and if you're missing a term in a polynomial, you would have to add, like, let's say I was missing this 4x term, I would have to add like 0x in there to get everything to line up if I was using this and I didn't have every single degree term in the polynomial. But in this case I did, so I was fine. So now all my like terms line up like that, so I can write this in standard form pretty easily. This is going to be x to the 4th plus x cubed minus 20x squared. No, wait a minute. Minus 21x squared minus 3x minus 2. Ka-chow. Okay, so there's, that's like a trinomial times a trinomial. It's got 9 monomials that you have to find the products of and add combined like terms. Here's a Pascal's triangle. We're going to talk about this a little bit, but I'm gonna leave that for now. So we might come back to that later. And I believe that's it, actually. Yep. So that is pretty much 6.1 and 6.2. We are just multiplying polynomials, defining the degree of them, naming them by names, degree, and terms. So hopefully you watched this 15-minute video over break, did some of the practice problems, and you come back ready to go after a nice 2 weeks. So have a nice break, and we will see you after the new year.